Hello, everyone, and welcome. I have decided to start this channel to go over personal projects that I have worked on. So, without further ado, let's start discussing the music mobile application that I've created. There are two disclaimers to go over before discussing the project background. The first is that this app was built before Spotify updated their developer terms of service, not allowing any machine learning algorithm to be trained. So this data has since been deleted. The second is that this is the first mobile app that I have ever made. Looking back, there are many things that I would have done completely differently. These changes will be discussed later in the video in the lessons learned section. In addition, as this was the first mobile app that I made, the UX and design is not good. I am by no means a UX designer. This project was purely to explore the machine learning use case for music recommendations. With all that being said, I am currently working on a second version of this app where I address many of my mistakes I made on this go round. A video on that project will be made in the near future. To start with the project background, the preparation for this project really began senior year of college, where I took a course in machine learning. In this course, we learned everything from regression to clustering to neural networks and how all of these topics work mathematically. Later on in the app development process, this information would prove to be extremely useful. Then, fast forwarding to after graduation, I began to learn mobile development. More specifically, I was learning Flutter and Dart. You may ask why I would use Flutter, as it is not the most popular way to make mobile apps, and the answer to that would be I wanted to develop for all platforms at the same time. Around this time, I had also been exposed to the power of cloud development via AWS, and this will all come into play whenever discussing the project tech stack, which the project tech stack for this app would be, like I said, Flutter and Dart, as it is a mobile app, AWS, and more specifically using Lambdas, API gateways, and DynamoDB. And then for the Lambdas, I would be coding those in Python. Now, the only piece of background left is the actual idea for the app. The main goal of the app was to allow users to expand their music tastes through different recommendations. I can personally say, just from testing this app, that I've added a few songs that I had never heard before to some of my playlists, so it does work. To achieve the goal of giving the user new recommendations, a swiping mechanic would be used similar to the popular dating apps on the App Store. If the user likes a song, they would swipe right. If the user does not like the song, they would swipe left. With this mechanic, the music recommendations could be refined over time as the user gives us more information on the songs that they like. The next question would be, how can recommendations be acquired for the user? The answer to this question would be different if I had a larger user base to make a recommender system with matrix factorization. Unfortunately, I had only a few users, so for this reason, matrix factorization would not work. The idea that would end up working is similar to k-means clustering, but without the clustering. The main idea with k-means clustering is to find centroids of various groups of points in a dataset with an iterative process. In this specific use case, the centroids do not need to be calculated, as the center of the data will be the average user point. All that needs to be done here is to calculate distances from the user point to song points. And thankfully, the Spotify API has this data to use. So to go over the algorithm in more detail, I've broken it down into a few different steps. The first task that we kind of need to complete, that will itself be broken down into a few sub-steps, is that we need to calculate the average user point. Again, the Spotify API has the data ready to use. The app just needs to hit two different endpoints to get this data. The first endpoint is the get users top items. From this endpoint, with the correct request body, a list of the user's top songs is returned. Next, each song can be turned into a point in the graph. Each song has 8 features that will be used to calculate this point. So after we get all of these top songs for this specific user, the last step is to calculate an average for each feature uh, and give that to the user. That is the average user point. Now that the average user point has been calculated, the next step is to calculate the distance between the user point and every song that is stored in the database. After we have that distance, we need to associate a probability with that calculated distance. The closer the song point to the user point, the higher the probability. Each time the user runs out of songs to swipe on, new songs will be recommended via these probabilities, and each song the user swipes on can move the user's point closer to what they seem to enjoy listening to. Now, as this video plays in the background, you will notice a few things. One, it is completely integrated with Spotify. You're able to add songs to playlists, create new playlists, add songs to your like songs library, follow different artists. It is completely integrated with Spotify. I mentioned creating playlists. There is an entire screen to go through the songs that you have liked on the run of this app, and you're able to select the songs that you want to, filter them, and create new playlists. And the final page that you will see in this app is a concerts near me screen. This screen shows concerts that are recommended for you based on the artist that you probably like. So, looking back and reflecting is an important part of the learning process. And looking back at this project, there are quite a few things that I would do differently. As stated in the beginning of the video, I am addressing all of these changes in the remake of this app. Again, there will be a video on that in the near future. The first lesson I learned is that I would have followed a significantly more structured front end pattern. This was partially due to lack of knowledge about front end development, but by the end of the project, I found it more and more difficult to alter features that I had already implemented. The code between the view and the business logic seemed to run together. To resolve this, in the next version, I've already implemented the block pattern. This pattern will allow for a much easier way to manage the code. The second lesson I learned is that I would have used Firebase instead of AWS. As I have gained more experience with Flutter, I have learned that Flutter plays extremely well with Firebase. Not that AWS was difficult to use, but setting up queues in Firebase and subscriptions to those queues would be significantly easier using a Cloud Firestore rather than DynamoDB. The final architectural change that I would make is to make the backend more responsible for more of the work. In this version of the app, the front end is doing a vast majority of the work and computations. And again, this is just due to a lack of knowledge about front end development, as this was the first app that I had made. But with that all being said, if you have any questions or notes, feel free to leave them in the comments. But that is all I had. Thank you all for watching.